Okay, this is going to look at what happens when you put the connection between charged particles and magnetic fields. First thing you need to know, and it's only quite a small bit of the course, is that if you've got a current with moving charges, then there's a magnetic field, a circular magnetic field exists around those moving charges. It depends on the direction of the current and the strength of the current, and you can look at that simulation to get a better idea, or maybe chase up a few more videos and things. Moving on, but if you've got a charged particle which is moving in a magnetic field, then it experiences a force which is perpendicular to the motion of the particle and the magnetic field. So it means that it's got to be moving across the field lines. That means that if you've got a charged particle which is going along the line of field lines, either against it or with it, then it doesn't experience any force, so it's not deflected. To work out the direction of the force, there are various hand rules. I'm going to show you what's called the Palmer's push rules, which means that you use your left hand for negative charges. Your thumb is the direction that the electrons, the negative particles, are moving. Your fingers are the magnetic field where it should go north to south. And the palm is the direction of push or force. And that works, the left hand works for negative charges. If you've got protons or alpha particles, then again the thumb is the motion of the positive charge. That should say positive charge, it will get fixed. The fingers are the magnetic field, and the palm is the direction of the push. So I've got a wee YouTube video here, which I did earlier, and so you can see that when it loads in, that I used some post-it notes on my fingers to show the direction, and it does load after a wee second. So here's my hand. I've got the thumb's the motion there, so that's the electron moving that way. This is for a negative electron, it's my left hand. Fingers are the field, and then the force is the push on the electron, so that's coming out. They're all at right angles. So I'll be coming up towards the screen, turn my hand over. If the electron's now going from left to right, then the push would be downwards. So because the force changes as the direction changes, it actually pushes it into a circular arc. So you can see here that if the field lines are coming out from the screen, it would go that way, and if the field lines are going into the screen, it would go that way.